So welcome back. In this video lecture, we are trying to draw the free body diagrams for the general case of forces in a plane. In the previous sessions we have drawn the free body diagram for the concurrent forces and as well as for the parallel forces. So there we have used the different kinds of concepts to find out the resultant component, and we have derived from the different equations. For that one, we have used the polygon law, triangle law and Lamis theorem because they are obeying the concurrent forces. In the parallel forces, we do have taken the forces in horizontal direction, the vertical directions, as well as the moments at a point. Then we have calculated the different types of the reaction forces. So now we are trying to draw the free body diagrams. So there I have given one example. A vertical mast PQ of a crane is pivoted at P, is supported by a guide Q. Find the reactions at P and the Q due to the loads acting as shown in figure. Right? So here I am going to be try to draw in pictorially. There we can see there is a mast, a PQ is going to be, and it is going to be a type of the crane. So then what will happen? So already we told the crane is pivoted at P, that is going to be in the horizontal direction, and the guide is going to be kept in the vertical directions. That means the crane is going to be moving. So this is going to be the vertical wall, and there is going to be a support we had given from the vertical wall, that is going to be the Q. Can you see at the rod P, it is moving in the vertical direction, and the Q is going to give the guidance to move maybe in the horizontal direction or maybe in the vertical direction also we can make it. At the same time, there is the loads are acting on this crane. So the first one is going to be the 2000 newtons and at a distance of 2 meters from the P rod. And similarly, another load is going to be acting at the end of the mast, and that's going to be 2000 newtons and at a distance of 3 meters between the two loads. So this way the problem has given, and he is asking to draw the free body diagrams and find out the reactions at P and the Q. And then what is the concepts we need to develop for draw the free body diagrams. So here I have taken the mast again. Okay, this is going to be the mast, and the next the loads are going to be acting, and then as we know that while drawing the free body diagram, first we need to remove the supports and then show with the reaction forces by assuming the motion of your body. So in this case, I am removing the support P and showing with the reaction forces. So that's acting, I am assuming that is acting in the vertical direction, and another force is going to be acting vertically, horizontal direction, and similarly the reaction force is going to be developing, that is Rx and Ry. These two forces are acting at a point P. So then what I am going to do? So I am joining these two forces. The component of the forces I am generating here is the Rp. So next there is a support at P is there by the guidance. So then what I am going to do? I am removing the supports from the vertical wall to the mast, and then I am going to be show, if I am going to remove the trying to body fall in which direction, it's going to be in the up forward direction, it is in the moving in the downwardly. That means it's going to be cover x as well as the y axis. So I'm going to be show with the reaction forces RQ. So then the body is going to be in the equilibrium condition. So these are the restrictions we developed to stop the motion of a body in a respective direction. So this way we are going to be find out the different types of unknown parameters. That's going to be the summation of the forces in horizontal direction is equal to 0. These are called equations of equilibriums. In vertical direction is equal to 0, and similarly the moments at a point is equal to 0. That is, the momentum of a force at a point is equal to the sum of the moments of the components in the same point is equal to 0. These are the equations of equilibrium we are using and we are finding. And here, to make you to better understanding of this free body diagrams I have given here, a man weighing 75 newtons stands on the middle rug, means here's one type of ladder, rug of 25 newtons ladder resting on a smooth floor and against a wall. It means one end of the ladder is going to be in the horizontal floor at A, another end is going to, the B is going to be supported at the vertical wall B. So in this case, 75 weight man is going to be standing there, and 25 newtons self weight of the ladder he has given. The ladder is prevented from slipping by a string OD is going to be connected at a distance. Find the tension in the string and reactions at A, B as shown in figure. So we need to find out the reactions at A as well as the B. So then how could you draw the free body diagram for this one? So at initial case, I have taken the ladder. So that's going to be A and B. I kept in the same orientation with respect to horizontal as well as the vertical. So then what I'm going to do, I'm going to be showing here the horizontal surface and then the vertical surface where it making a contact. So then I'm going to be showing with the 75 newtons the self weight is going to be at the middle. That means a man is standing on the ladder. And the next one, 25 newtons is going to be the self weight of the system which is acting at the point C. And we have connected with the rope. So that is going to be generating the tension to avoid the slip. So then what I am going to do? I remove the support at the A. Then what will happen? The body is trying to move in the downward direction. That is my assumption. And then I have developed here is the reaction force in the upward direction. Then the body is at the equilibrium position at A. And similarly, I am going to be removing the vertical wall where we got a support at B. And then I am showing with the reaction forces opposite. That means this is going to be in the horizontal direction. So we need to assume that always the contact point with any body, that's we need to generate the perpendicular. That means normal forces are going to be generating from the contact surfaces. The next, what is we need to remove here? Yes, we need to remove the OD, the string which is connected. So in this case, I removed the string and shown with here is the tension, because these strings are going to be consist of the tensions. So then what I am going to do here? So in this way we have drawn the free body diagrams, and then what is the main outcome from this one? We are able to understand what is the free body diagram, what is the importance and the function of the free body diagrams, and where it is going to be generating the reaction forces and the restricting the motion of the body, and how to assume the motion of the objects, and how to develop the reactions or restrictions to the motion, and how to assume the reaction forces, and how to use the equilibrium of equations we have seen. So this way we are going to be learning the different types of the free body diagrams. So thank you. So I'm making the series of video lectures to make a better understanding and develop the skills of free body diagrams and to identify the different types of the reaction. Please follow my channel. For more updates, I will be there. Thank you.